So looking at we'll start with number 23. If you look at 23, you have a circle, and then you got a 30, 60, 90 in it. So if you're drawing this, you're going to have to draw this on your paper because they tell you to draw some stuff in on it. So you're going to want to draw it also. It's on page 501. If you take a diameter straight through the center, they've actually put in a right triangle within that semicircle. And you have a 30, 60, 90 in there, so you want to make sure you label it the way they did, though. One thing I'm going to do is go ahead, and you're probably going to want to do this too because eventually you're going to need to do it. I would draw the right triangle also, a copy of it outside the circle, because at the very end of this we're going to need to label it. So it might help to go ahead and have it drawn, and it'll make the end go a lot faster if you do that while you're drawing anyway. Okay, so y is the measure of AB. Let me kind of outline as we go. AB plus BC equal to ABC. What do you think that's going to be? Yeah, that's an arc addition postulate. That's why I read you the formula, the theorems out loud first. That's the arc addition postulate. Okay. Again, you can just write down the answer or the reason. You don't have to write all this that I'm doing down. Is AB plus BC equal to AC? They're asking you.
The size of the triangle?
They want to know the size of the triangle. Are those equal?
No.
No, they're not, are they? That. The Pythagorean theorem, right? You could say we know the relationship they have. They're not equal, but we could put no first, and you could put AB squared plus B. Oh my gosh, I can't do anything right today. AB squared plus BC squared equal AC squared. I need a bigger marker tip. Do that. So we know the relationship, and it's not that they're equal. And the reason you know that is because didn't we just talk about it, right? About that the inscribed angle is half the intercepted arc. Okay, 25. Copy the figure and draw OB. Okay, well, I'm going to draw it here. OB1. Kenobi. Also label it R. Okay, so it's R. OB is the radius, and it's going to be R. Did I draw that right? What else would be a radius in this circle that... Yeah, OA and OC. Now, if that's R and that's R, notice I drew my triangle separately down here, and this is Y. In a minute, they're going to ask you for all these sides. That's a diameter, so isn't it 2R? Let's write it down there, because we're going to need it in a minute, because I already did it with the 9th graders. I just didn't record it. So 25, you're just drawing that on there, and you're labeling OB is equal to R. I'm just going to put draw on that. Find the measure of AB, arc AB. So they want to know what is arc AB. I can write it arc AB equal, or I could put an M in front of it to say the measure of arc AB. And they want to know the measure of arc BC. And then they want to know the measure of ABC.
Could we make the chord from A to B R as well? Because right now that triangle is framed by 2 R's, so then that make it angle. So they know to make it...
It is going to be R in a minute, and I'll prove to you that you're right. Right now, you might want to be careful about that, but actually you're just thinking, you're answering a question they're going to ask in a minute, okay?
Oh, okay.
Okay, so they're going to get to that. When we want to know the measurement here of AB, if you look in your book, it might be easier to see. Do you see that what's going on here is that AB is cut off There's an inscribed angle of 30 degrees here that cuts off AB. And what's an inscribed angle? Where's the vertex? On the circle, not at the center like we were used to getting. It's on the circle. So if that's a 30-degree angle, the arc AB is going to be double the 30-degree angle. That's one of the, okay? So 2 times 30 would make arc AB 60 degrees, right? Okay? Now BC, I'll pick a different color because I'm really messing my figure up here. BC, if you look, and you might want to look at your book because this is getting awfully messy, there's an inscribed angle that cuts off arc. It's 60, right? The inscribed angle that cuts off BC is 60 degrees. So remember, the arc is double the angle, so 60 times 2 would be 120. Now, ABC, if you trace it, what is it actually? It's a semicircle, so it's 180. What now, Jessica?
Okay, no.
What were you saying? Because I actually...
It kind of confused me. I thought you put one... Never mind, I messed up.
Yeah, 120 is BC. Now, could we find it by just adding these two together? Because if we add these two together, they make up... Actually, that's what we set up here in step 23, right? That if we add them together, we get the whole arc. So we could just say 20 plus 60 plus 120 is 180. Because we up here, we had just said that we could get the whole thing by adding them together. So we could have found it just by the arc addition postulate. We could have just added those together, but we can also see it's a semicircle. So that's kind of good. It kind of shows you why that's working out the way it is. And again, you might want to refer to the book because this is getting awfully messy. Any questions about that? Good. Okay, 27 says express AB, BC, and AC in terms of R. Okay, this is why I drew the separate triangle. Let's label our triangles with A's. We know how to label a 30, 60, 90, right? Across from 30, we call it A. Oops, I meant to do that in a different color. Across from the 60, we call it, that was the A squared of 3, and the 2A is the hypotenuse. Okay, so yeah, one of them is 2A, but it's the hypotenuse. Now, look right here. A and R are the same thing in this, aren't they?
Mm-hmm.
Okay, so if we talk about AC, AC is just 2R because they want us to label them in terms of R. AB is just A, but we know that A and R are the same thing, don't we? Does everybody see why they're the same thing? Okay, because 2R is equal to 2A. You could actually set them equal and divide the 2 out, and you would get A equal R. AB is going to be A, but we know that A is R, so we can just write R down. And then BC would be, if A is equal to R, wouldn't BC be R square root of 3? So all I've done is I've labeled the triangle with our labels that we're used to doing for a 30, 60, 90. But the reason it's turning out the way it is right here where I'm circling in yellow, because I see some people with some faces kind of like, I'm not sure I'm seeing that. If that's 2A when I labeled it, we got 2R up here, because remember, that's this line right here, and here's a radius, and here's another radius, so R plus R would be 2R. And 2R is the same thing as 2A. So isn't A equal R? You just, you could divide, you could set them equal, divide 2 out, and you'd get A equal R. Okay, sorry, we just looked back at number 27. AC is 2R, AB is R, R plus R is 2R. Okay, so now they want us on 28 to say, how are the measure of arc ABC and the measure of arc AB related? Okay.
I guess it's 3 times.
Let's see.
Yeah, because...
Yeah, this is 60, right?
Times 3 would get you the semicircle.
Yeah, this was 60 here, and the whole thing was 180. So you could say measure of ABC is 3 times a measure of arc AB, right? Because the whole arc is a semicircle. It's 180 degrees. And we know AB is 60 degrees. And so 60 times 3 would give me the 180, right? So I'm just kind of looking at numbers. It's so cluttered up there now, it's hard to see. Did we write AB? Yeah, remember, look at 26 if you're confused. AB is 60 degrees. ABC is 180 degrees. Couldn't I multiply 60 by 3 to get 180? Okay, so that's where that's coming from. I'm going to go to a new slide here just because it... So 29 says, measure of arc BC is equal to twice the measure of arc AB. And remember, we just said that 3 times the measure of AB was equal to ABC, right? So I'm just writing that down from the last problem because I have a feeling I'm going to need it now. If measure of arc BC is 2 times the measure of arc AB, how are BC and AB related? What? Let's look back at our 30, 60, 90. Let me try to read. This was R, this was 2R, and this was R squared of 3, right? And my 30 was here, my 60 was here. That's where all that came from. And this was B, and this was C, and this was A. And they're actually asking us about the arc. So let me just draw them in. So BC, how is it related to... BC is this line here. How is the line related to AB?
BC equals AB times the square root of 3.
Yeah. If you take R, you multiply it by the square root of 3, you would get R squared of 3, right? So if we're just kind of looking, that R was AB, and that would be BC times the square root of 3. So, no, I got that backwards, didn't I? I got that backwards. Let me put one line through it. Is it
BC
AB times the square root of 3 is equal to BC? There we go. Now I got it right.